Video we will solve this problem. It asks for the flux, and this is your vector. The surface is this cylinder between these planes, and well, if we try to calculate the flux interval directly, we will need to take into account the two end caps and parameterize the curved part of the cylinder. And since that's way too complex, we can use divergence theorem, because it will transform that really complex flux interval to a one single triple integral over the enclosed volume. So we're gonna do that. And the divergence theorem says that the flux interval equals to the triple integral of the divergence of f. So we transform into vector. And this is the equation, but so we need to calculate the divergence of this, and we're just gonna calculate the partial derivatives of each element with respect to x, y, and z. So this with respect to x, this with respect to y, and this with respect to z. So it's going to be equal to this, and since these are constants and the partial derivative of x with respect to x is 1, we just get 3 times j squared plus 0, because all these are constants with respect to y in our derivative, so it's 0. Then that's going to be 3 times z squared. We have to explain that it's just 3 minus 1. Alright, so we have this. Then we have to notice that the cylinder has circles. Well, it's a elongated circle, so we can use polar coordinates because it will make everything much easier. And it already has the general form, so the circle in the GZ plane is this. Well, it's a cylinder, but a circle. And well, this is just the radius, so we can write it like so. And well, here we can factorize the 3, and since we already stated that this equals r squared, we just write 3 times r squared, and then we have to define our limits for our integral. X is already given that goes from -1 to 2. Then the radius go from 0 to 1. Okay. And the angle goes from 0 to 2 pi. And then we just use everything that we calculated to perform our integral. Or differential vector, it's dx or dr differential of the angle. So I'm just gonna multiply the r directly, and we get this. Now these are really simple integrals. First we calculate this one, which gives the evaluation of 3r to the 4 divided by 4 from 0 to 1. Since this 0, since r is not in an exponential form, we just ignore that 0, and this one substituted here, 1 to the 4, it's just 1. So this is just going to be 3 over 4. and then we just calculate the rest. Here what we got from here, I took it out of the integral, and this is just x evaluated from -1 to 2, so three, and then we just got one integral more. This is just the angle evaluated from 0 to 2 pi, which gives 2 pi, but if we want to be specific. And then we just multiply our results. 3/4, 3/4, I think, multiplied by 3, multiplied by 2 pi, gives 18/4 times pi. And if we simplify this, it gives 9/2 divided by pi. And that's our final answer.